So letter E is all about the derivative function. This is where we make our biggest connection to calculus. In calculus, there are three main ideas: limits, which we've talked about, the derivative, which we're getting ready to talk about, and integrals, which we'll talk about later. So we've actually already learned about the derivative, we just didn't call it the derivative. The gradient function of y equals f of x is called the derivative function, and we label it f prime of x. So we found tangent line slopes. What the derivative finds is the actual function, and so we can call it the gradient function, but typically we call it the derivative. Just like you learned add and subtract or inverses, multiply and divide, inverses, exponents, logs, inverses, calculus has derivatives and integrals, which are inverses. So the next focus for the next couple months will be all about derivatives. So just analyzing a graph, if we look at this particular graph, it says find f prime of 4. F prime is the derivative of the tangent line, or the slope of the tangent line. Well, they have the slope drawn in. They have the tangent line drawn in. So we need to find the slope of that particular line. So I'm going to find the slope of the line. So on this line has the point 64, but it also has the point 20. So if I find the slope of this line, that actually gives me the derivative at this point, because the point at 4 is on the same line here as this slope. So I'm going to do my y minus my y over x minus x. So 4 over 4 is 1. Because the slope of the line is 1, the f prime of 4, the derivative function at 4, is also 1. That's section E. I'm also going to tie together section F and put it all in the same video. So there are most of the time we don't have a nice pretty line like in section E that we can find the slope of the line of. So then we go back to the derivative function, which is our limit as h approaches 0 of f of x plus h minus f of x all over h. So whenever we find the derivative, f prime of x, the derivative function is found using all of this. Okay, so they call that using first principles of the gradient function. So if f of x equals x squared, to find the derivative function in terms of x, we're going to take the limit as h approaches 0 of f of x plus h minus f of x all over h. So if f of x is x squared, what does f of x plus h equal? X plus h squared. So I have to keep the limit as h approaches 0. F of x plus h is x plus h squared. I'm going to simplify that though. So that's x squared plus 2xh plus h squared, just distributing all of it out, minus f of x, but f of x just equals x squared all over h. When you do this correctly, the x squareds cancel. I'm going to bring down the limit as h approaches 0. Now, when you do this correctly, everything has a GCF of h in the numerator. Factor out the h. So the h cancels. Now I can substitute my 0 into h, and my limit is 2x. What this tells me, f prime of x, the derivative function, is 2x. Now let me draw a graph. And actually, they had a better graph. Oh, you know where it's at? Let me see if I can find it. Here. This is a good approximation of x squared. So I'm going to use this graph. Remember, we just found that f prime of x equals 2x. So what that does, I can find every single tangent line on the graph and I don't have to solve it individually for every single point. F prime of -1 is 2 times -1, or -2. That's saying when x is -1, the tangent line has a slope of -1. What is f prime of 0? 2 times 0 is 0. That means at x equals 0, the slope of the tangent line is 0. If I plug in a +1, I get 2 times 1, which is 2. So when x is 1, the slope is 2. So what we're finding is all these, see how this is a downward slope? All of these on to the left of 0 are going to be negative, because 2 times a negative number will be negative. At 0, it's going to be 0, but everything on the right side has a positive slope. It's going to be 2 times its x value. That's going to be the slope of the actual tangent line. Okay, so let's look at letter A. If our function is x to the 4th, this one it's gonna be helpful to remember the Pascal's triangle to distribute this out. Because in order to find the derivative, that's the limit as h approaches 0 of f of x plus h minus f of x all over h. So when I want to find f of x plus h is x plus h to the 4th minus x to the 4th all over h. So here's when we want to simplify x plus h to the 4th. I'm going to look at Pascal's triangle. This is where it's squared. This is to the 3rd. So if I want to find x plus h to the 4th, I'm going to use this row of coefficients. So that's 1 x to the 4th plus 4, x goes down to the 3rd, h goes up, plus 6, x goes down, h goes up, plus 4, x goes down, h goes up, plus the x is gone, h to the 4th. Then I have to subtract x to the 4th all over h. The x to the 4ths cancel. All right, rather than rewriting all of that, I'm going to factor out my h right above here. Oh, there's h there. Then I can cancel this h. I can plug 0 in for all my h's. And I'm only left with 4x to the 3rd. This tells me the derivative of f of x is 4x to the 3rd. So if I find the value for letter B, f prime of -1 is 4 times -1 to the 3rd, which is -4. On the graph, x to the 4th, that's just a really steep u. at -1, it's got a tangent line that has a slope of -4. And that is section